Hey Brown Bombers, it's Miss Morel, and today we're going to be talking about section 4.3, how atoms differ. So our goals of this section are to explain the role of the atomic number in determining the identity of an atom, to define an isotope, explain why atomic masses are not whole numbers, and calculate the number of protons, electrons, and neutrons in an atom given its mass number and its atomic number. We'll have some vocabulary that will be review and also some new vocabulary, of course. And then the main idea is the number of protons and the mass number define the type of atom. So atomic number. Each element contains a unique positive charge in their nucleus. And so the number of protons in the nucleus of an atom, that's what identifies the element and is known as the atomic number. So here you can look at hydrogen as our example. And so the number on top is number 1, and that's its atomic number. And so that actually tells us how many protons are in the nucleus. All atoms of a particular element have the same number of protons and essentially electrons, but the number of neutrons in the nucleus, they can differ. So atoms with the same number of protons but different number of neutrons, they are called isotopes. And we'll be talking about those a lot. So make sure you remember what exactly is an isotope. And again, that just means that there's different numbers of neutrons. So in nature, most elements are found as mixtures of isotopes. Usually the relative abundance of each isotope is rather constant. So for example, in a banana, there's 93.26% potassium, 39, 6.73% of potassium 41, and 0.01% potassium 40. So in another banana or in a different source of potassium, the percentage of composition of potassium of all the isotopes essentially is the same. So isotopes containing more neutrons have a greater mass because neutrons, they are kind of big and weigh a lot. Isotopes of an atom have the same chemical behavior. So the mass number is the sum of the protons and neutrons in the nucleus. So here we can see potassium 39, and we can see that this is the protons plus neutrons. And potassium 40, again, protons plus neutrons. And potassium 41, protons plus neutrons. Are you getting the hang of that? All right, so one atomic mass unit is called an AMU. It's defined as 1/12 the mass of a carbon-12 atom. So essentially, we're going to be talking about how much things weigh when we talk about an AMU. The atomic mass of an element is the weighted average mass of the isotopes of the element. So we won't do a lot of calculating on that. We'll start to get the hang of it. You'll do a lot more if you take chemistry in college. So most importantly, I want you guys to be able to identify the number of protons, neutrons, and electrons. So let's take a look here at boron. So boron, it has an atomic number of 5, and we're going to say its atomic mass, or its mass number, is 11 because we're going to round this. So how many protons does it have? Well, we just look at its atomic number. There are 5. Next, how many electrons does it have? Now, the pretty cool thing is that in a neutral atom, it has the same number as protons. So protons equals electrons. So again, we just look at the atomic number. It has 5. And then lastly, how many neutrons does it have? So this requires a little bit of math, but nothing to worry about. It's not anything you didn't learn in first grade. So atomic mass, we take that and we subtract the atomic number. So 11 minus 5 is 6, right? So that means there are 6 neutrons. Let's look at one more example. How many protons? We look at the atomic number. There are 14. How many electrons? Again, we look at 14. Then we're going to round the atomic number, or the atomic weight, the mass of it. So it weighs about 28. 28 minus 14 is what? It's 14. So it has 14 protons, and we get that from the atomic number, 14 electrons, which we get from the atomic number. But then how many neutrons? We have to subtract the weight from the atomic number, and we still get 14. All right, guys, I hope that's starting to make some sense.